Hello, welcome to my YouTube channel. Today I want to talk to you about imaginary numbers. Um, so, a lot of times in my algebra classes, we talk about this idea of real numbers, right? Maybe we're talking about domain and range, and we say all real numbers, or our solution for the quadratic is all real numbers, or we have two real solutions, or something like that. So a lot of times I get question then from that is, well, if we have to specify real numbers, does that mean there's such a thing as not real numbers? Is there fake numbers? And there is. There's imaginary numbers, which is something that you learn about in Algebra 2. So I want to talk about imaginary numbers and sort of what they are, where they come from, what the definition is, and then a little bit about how we can use them. Okay, so in order to do that, we need to talk about, or we need to understand what a square root is, okay? So the square root is a function that we use in math to say what number multiplied by itself will give us this number here, kind of inside of the square root. So this little check mark with the line on top, right? That's called a radical or a square root. And this number inside, the 64, is saying what number times itself will give us 64. Okay, so you might already know the answer to that is going to be 8, right? 8 times 8 is 64, so the square root of 64 would be 8. There's also another option, though, right? Because we can multiply negative 8 times negative 8, and that will also give us positive 64. When I multiply two negative numbers, it becomes a positive, okay? So we're going to keep that in mind as we kind of go forward and look at the next piece, right? So instead of doing the square root of positive 64, let's take the square root of negative 64. All right, so instead of 64, we have a negative number, right? And so now, when we try to put this in the calculator, if you do it right now, right, your calculator will say error, right? Because you cannot take the square root of a negative number because there's no real number multiplied by itself that will give you a negative. Remember, 8 times 8 positive will give us a positive, and 8 times 8 negative will also give us a positive 64. So there's nothing considered a real number here that's going to work for our case. All right, but we're not done here. We can actually simplify this a bit more and use some of our algebraic properties to manipulate this and make this work. So to start, what we're going to do is we're going to take this negative 64 and we're going to factor it to be negative 1 times 64. Okay, and so what that does is we're not changing the value of what's inside of or underneath of that square root. We're just saying we're going to break it into two pieces. Okay, and then we're going to use the product of powers rule to further split this up a little bit more into separate square roots. So the square root of negative 1 times the square root of 64. Okay, and so the overall value of the whole thing is still the same. We've just kind of used algebra to manipulate it for our own purposes, okay? And the square root of 64, remember, is 8. All right, so we can simplify that there. And then I'm just going to rearrange these two. I'm going to put the 8 in front of the square root to show, first of all, it's not inside of a square root anymore. And second of all, it just looks a little bit neater, okay? So now this here is where our definition of the imaginary number comes in. Because our imaginary unit is the square root of negative 1. Remember, we can't get any real number times itself to give us negative 1, so this is kind of our basis or our starting point. And instead of writing the square root of negative 1 over and over and over, we're just going to use the lowercase I to represent an imaginary number. Okay, so we've got the imaginary number I, and we're just going to rewrite this as 8I instead of 8 times the square root of negative 1, knowing it means the same thing. Okay, and this is what's called a pure imaginary number of the form b times I, or bi, right? Where b is that real number, 8, and then I is our imaginary unit. Okay? And so this is going to be a separate type of term from our real numbers. And so if we're doing some kind of math, we're doing addition and subtraction, right? We can't combine unlike terms, right? We cannot combine a real number and an imaginary number. So if I add a number like 5, right? Pick a random number here. Let's say we had 5. Okay, we would have to represent this quantity as 5 plus 8i. The same way we might write 5 plus 8x, right? They're different kind of terms. They don't combine the way that real numbers are combined with each other. Okay, and so this right here is called a complex number, and it's of the form a plus bi, where we've got two real numbers a and b, and then I is that imaginary unit, right? So 5 would be our a, 8 would be our b in this case that I'm showing right here. So that's kind of the first part. That's kind of our start of using imaginary numbers in this thing that's called complex numbers. And you can mention that to your Algebra 2 teacher to kind of impress them if they haven't taught you that yet. And then the other thing I want to talk about is if I take the square of I, right? I is the square root of -1, but if I square that, we get actually -1. So I can take the square of a imaginary number and get a real solution. So I think this is really fascinating, and it has all kinds of implications, which you'll see when you get to this in Algebra 2. So I hope you like this video. Let me know what you think in the comments, and thanks for watching.